All right, so today we're going to just recap a little bit gradient and y-intercept from the last class. So the title of today would be gradient and y-intercept of a line. So it's voluntary whether you take notes on this because it's a bit of a recap of what we did the last lesson. So it's more using our Cartesian or coordinate plane. We're looking at linear graphs, so that's lines. We're going to be looking at the gradients and the y-intercept. So the gradients is how steep, and the y-intercept is where it crosses the y-axis, which is this thing, so it's a point. All right, so in the work today, you're going to be asked to find gradients and find y-intercepts of lines. I'm not going to spend too long on this. I'll just use this as one example. Okay. Thanks, Amir. All right. So I'll come back to this diagram in a second. First of all, we need to remember uphill, downhill, and flat. Okay, so uphill, downhill, and there's two types we can have. We can have flat like that, or we can have straight down like that. All right, so when we're considering gradients, it's like a guy approaching a mountain. He's going to go, if it's uphill, it's positive gradient. If he's here on top, he's going to fall all the way down. It's a negative gradient. If it's flat like this, that means he can stroll along nice and easy, no problem. Zero gradient. And if there's a barrier here, he has a sad face. It's called undefined gradient. Okay. So we always read gradient from left to right, and if there's nowhere we go from left to right, it's undefined. It's like a barrier, it doesn't count. Because gradient is a fraction. And something called, you count the rise and divide it by the run. So if it goes up a lot, as it goes over only a small bit, that's going to be a very steep graph. But if it goes up a bit and it runs over a long way, so if you think about that, I just make a rise. So if this is rise and run, so like that, rise and run. And that's how we look at a line. We make this triangle. We go, okay, that doesn't look very steep. If it has a short rise over a long run, it's not very steep, is it? But if I have the opposite effect, a short run and a long rise, well, that's going to be a tough mountain to climb. That's a very steep slope, so it'll be a very top-heavy fraction. Think about it. So if you wanted to put it in centimeters, which you can, if that's just 2 centimeters over, this looks about 10 centimeters up. What would be the gradient of this? Well, it's going to be the rise of 10, because gradient is the rise divided by the run of 2, which I could simplify down. 10 over 2 is 5. Okay, so that's gradient in general, and it's always, gradient will always be rise over run. So that is something definitely you need to have in your notes, and maybe have a little diagram underneath so you notice. Rise is how far up it goes or down it goes, and run is how far along it goes from left to right. Now, so and we have our 4 different, it could be a positive slope, so both these were positive, so that just would be a plus 10 over 2, but if it was going the other direction, if it was going downhill, you just put a negative in front of that slope. Negative 10 over 2. Okay, so I'm going to draw a line here on my initial diagram. Make sure I'll just get it off screen so I can draw straight. Okay, so I've drawn in this line here, so that's a linear relationship between x coordinates and y coordinates. Remember, we can put that in the table. We can plot points along it. It's just a load of points joined together, isn't it? First of all, I'm going to look and see, well, is it an undefined gradient? No, it's not. It's diagonal, so it's fine. It's not flat either. Is it positive or negative in slope and gradient? It's going downhill, so it's a negative. My answer is going to be negative. But how do I actually calculate what the rise of the run is? Well, I need to just count squares. So in the worksheet you're going to be given, it's a matter of counting squares. How far over it goes and up it goes. So you form a triangle like one of these triangles down here. And you usually use one of the axes. So I'm just going to use the axis as x or the y-axis. Maybe I'll form one back here. Okay, I'm going to just form that triangle here. So there's a right angle triangle. So right angle triangle. All right. So I'm going to look and I'm just going to count the boxes. I'm going to find out how many boxes here for the run. 2 boxes for the run. So that's 2 below the fraction. Remember, run goes to the bottom. And how many boxes? Oh, that's also 2 on the rise. So 2 over 2. So I just counted the boxes. 2 over 2 is 1. 2 divided by 2 is 1. But that's not the slope. I've left out something very crucial. This is downhill. So the gradient of this line, or slope of this line, is minus 1. It goes downhill. Minus 1. All right. Did it matter where I put the triangle? No. Let's have a little look. Why? If I put another right angle triangle here and just did the same count, so I need to just extend this a little bit more. How many boxes over does it go? 1, 2, 3. So it goes over 3. So that's a run of 3. And it goes 1, 2, 3. And it's the rise of is 3. Well, it actually goes down 3. You can see. It's going to be the same ratio. 3 over 3, which is also 1. And then it's downhill. So minus 1 is the answer. So it doesn't matter where. You can pick any place. It's just easier to count boxes in some places than others. So pick a place. It's easy to find a right angle triangle and easy to count the boxes over and down. And then just write your gradient as how far it goes up or down on top of the fraction and how far it is moved over on the bottom of the fraction. So no matter where I draw this triangle, it will be, so if I drew a large triangle, it would be 6 over 6. If I draw a small triangle, it's going to be 5 over 5 or 1 over 1. It's the ratio of those two because it's just a simplified version of the fraction. For the y-intercept, well, that's just where it crosses the y-axis. So the y-intercept of this is actually coincidentally minus 1 as well. So because it crosses here at minus 1, but if it went through minus 2, it would be minus 2. Now, what you guys are asked to do for the most part, for green and yellow, is just try and find these gradients. So draw a right angle triangle, just count the boxes. For every 1 or 2 it goes over, how much does it go up or down? And then just write in the slope. Remember, uphill positive, downhill negative, and flat is 0. And then you'll also have to use from what we did on Friday, the y is equal to mx plus c. Now, if you remember that, the gradient was the letter in front of the x. That's the gradient. In this case, it would be minus 1. So I could write that if I wanted. For this line, y is equal to minus 1x. So that's minus 1x. And c is where it crosses the y-axis, and this is going to be also minus 1 in this example. So this is the y-intercept. Now, we did that on Friday, so hopefully that's just a quick reminder. And that would be the equation of the line, but we don't really need to do this today. We're just trying to calculate the gradient looking at the line. So let's match our counter boxes. Let's see how we get on. It's not going to be too much of an issue at the moment if you're not quite getting the right triangle here, but definitely try and If you can't read it off the screen, maybe try and draw it, but you don't need to draw these lines because it's just easier to read it off the screen and try and count the boxes. All right, any questions on any of that? So you're probably wondering what the work is.